Hello everyone, welcome again in Eng-Man YouTube channel. So we will continue our learning on oil network modeling using GAP software. Okay, so now we will try to answer the next big question for us. And the question is, for how long the system can produce at the maximum capability of 20,000 stock tank barrel per day? To answer this, we will involve prediction in the GAP. So to answer to the question, a prediction from December 2010 to December 2020 can be run. The prediction needs to be run with optimization so that GAP can honor the liquid constraint that has been placed at the spirator. And again, the liquid constraint is 20,000 stock time barrel per day. This constraint has been applied so that the restricted capacity of the spirator in the field is captured in the model. Whenever applying constraints in GAP, they should correspond to a physical constraint in the field. Like in this case, it's real and it's practical, it's a physical constraint in the field, which is maximum liquid production that the network can handle, which is 20,000 stock time barrel per day. The best practice is always to apply constraints in this manner and keep the constraints to a minimum, as a greater number of constraints will require a more complex optimization problem to solve. Okay, so to run the prediction, we go to prediction here and then run prediction. All right, so here we have reservoir A, reservoir B. The status for the ML model are okay. We have start of production relevant to the MBAL software here, and the end of history is contained in the MBAL file, and the value is here. The date is here. Okay, so now we will start the prediction from December 1st, 2010 through December 1st, 2020. Here, the setting for the date is day, month, and year. And note that the start of prediction is set at 1st December 2010, which coincides with the end of the history of reservoir B. Here, the prediction must be run from this date or earlier, as otherwise the reservoir pressure in reservoir B cannot be calculated, as it is dependent on the produced fluids, which will have to be assumed. Okay, so we just continue the calculation starting from the end of history of reservoir B. All right, once again, note that the start of prediction here is set at this date, which coincides with the end of the history in reservoir B. The prediction must be run from this date or earlier, because otherwise the reservoir pressure in reservoir B cannot be calculated, as it is dependent on the produced fluid, which would have to be assumed. If we don't, connect the start date with the end history of reservoir B, then we cannot calculate, we cannot predict the reservoir B. Or otherwise, you should, provide the assumed produced fluid for reservoir B in the gap between the last day or the end of history of reservoir B and the start date of the prediction. Okay, so now let's click on next. All right, and then set the prediction next again here, and the spirator pressure next, still 200 psi. Okay, now let's set the optimization or the mode to be optimized with all constraints, and then let's just calculate. The computation hopefully is not for long, still on progress. You can also check the limiting. You see the limiting element is the spirator, of course. Go back to the log. Okay, please be patient. Events, constraints, go back to the log. Later you can plot tanks, you can plot nodes. Okay. Okay, maybe I can pause it for a little while. I will show you the result later. Or maybe I will just close the video here. So this video is focusing on, running the prediction. Until this calculation, I'm going to stop the video here. In the next video, we will check the results for how long the network can keep the maximum liquid production rate, how long this network can maintain or can, achieve the constraint. And we will see later the total production rate, the cumulative production rate, but that's a story for, for the next video. Until then, see you and thank you.